Hello, welcome to the session. Am I audible? And is the screen visible to you? Oh, thanks. So, okay. So before starting, let me know, do you have any question or a doubt from previous session or any doubts from assignment whose answers have already been released?
सर मेरा जो बैकग्राउंड है वो फिजिक्स का बैकग्राउंड और मुझे मैथमेटिक्स में मतलब थोड़ा बहुत रियल एनालिसिस
One second.
है।
Can you please be louder?
हाँ सर, मैं जो है मेरा बैकग्राउंड जो है फिजिक्स बैकग्राउंड से हूँ सर मैं। और मुझे टोपोलॉजी इसलिए सीखना है क्योंकि सर वो एक स्ट्रिंग थियरी के लिए थोड़ा बहुत इसका जो है इस्तेमाल आता है थ्योरेटिकल फिजिक्स में पर्टिकुलरली। तो
अच्छा, ओके.
मतलब मुझे यहाँ पे लाइक इतना ज़्यादा समझ में कुछ भी आता नहीं है जो जो अनंत सर का लेक्चर है उनमें। तो मतलब मैं क्या कर सकता हूँ? मेरे पास कोई बुक्स नहीं है और जो नोट्स है उसमें लाइक नोटेशंस में थोड़ा बहुत सर प्रॉब्लम है।
Okay, one second. So, one second. Tell me one thing. Which parts are required for your string theory?
सर ऐसा कोई मैंने मतलब सर्च नहीं किया है। मुझे एक्चुअल में सर मुझे मैथमेटिक्स पसंद है एक तरीके से, तो इसलिए मैं टोपोलॉजी टोपोलॉजी मुझे इतना पता है टोपोलॉजी के बारे में कि वो बस एक अभी 20 टू 30 इयर्स पहले ही जो है न्यू बॉर्न मतलब ब्रांच है मैथमेटिक्स की। एंड बस मतलब और थोड़ा बहुत लाइक नॉलेज है कि अलजेब्रिक टोपोलॉजी होती है, फिर डिफरेंशियल टोपोलॉजी होती है वगैरह वगैरह।
Hmm. If you can tell me the specific part which is needed, then I can help you better. Actually, I mean, if it is possible for you to tell me some term at least, then also I may guess. But if you ask them the topology, then it's a very vast area, right? I mean,
ऐसा
you might have heard some kind of terms, of course, right? So can you please tell?
मतलब इसमें लाइक कैसा है जैसे कि प्योर टोपोलॉजी और एप्लाइड टोपोलॉजी मतलब ऐसा कुछ है
No, 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 no,
जैसे।
no, not like that. Suppose, suppose quotient topology. Suppose Mobius strip spheres. Suppose fundamental group, cohomology, homology. There are some kind of this type of terms are there, right? So have you heard any something, some new kind of term, or some have you heard some kind of term regarding this thing? I mean,
नो
related to string theory.
नॉट येट आई मीन अभी तक मैं मतलब इतना नहीं मैं अभी एमएससी 4 के मतलब इंटीग्रेटेड एमएससी का कोर्स है। इसमें मैं
Hmm.
सिर्फ 4 ईयर में हूँ अभी। तो मैं बस अपने जो डिसर्टेशन है फाइनल ईयर का तो उसके लिए प्रिपरेशन के लिए ये ले रहा हूँ।
Got it. Okay. So you can do one thing. So you of course need to understand the basic topology, and I am assuming that you don't have that knowledge right now. Am I right?
यस।
Okay. So tell me one thing. Till now, which topology books have you read till now, or you did not read anything till now?
नहीं अभी तक नहीं। नो नो नो।
Okay, got it. So one second. So you can start with you have of course you have heard about the book Manfred, right?
आई मीन सर नो नो सर सॉरी।
Oh no! Oh, sorry. You are from figure. Sorry. So there is one second. Yeah. So there is one book named James Manfred's. Okay, topology. This is the most famous book for topology for the beginners. Okay, you can go with this book. It is well and good actually. Okay, I mean yeah, it is well and good. This I mean the authors start with by introducing basic things and gradually get into deeper. But this book is good to go. So you can start with this book itself. Okay, no, you no need to do any kind of search in over internet or there is no so you will not be in any confusion. Simply take this book and finish this book. I mean up to which part is necessary. That's it. Okay,
ठीक है।
understand. So try to go with this book. I think this will be pretty much helpful for the student. At least you should know the basic. Then only you can understand. which part you need to read or which part you don't need to read. So this book is good for basics at least. Okay, so go with this book. Okay.
हाँ। एंड सर मतलब
Yes.
मेरा जो है फिजिक्स बैकग्राउंड, लेकिन उसके बाद अगर मुझे मतलब मैथमेटिक्स में पीएचडी चाहिए तो कोई पॉसिबिलिटी है?
So
जैसे
tell
गेट
me one thing. Tell me one thing. Right now you are doing USC from where?
एसयूएनआईटी सूरत।
NIT Surat, right?
या,
Okay. So you have gave you so you have you wrote the net and get this time?
हाँ सर, गेट या गेट ओनली गेट।
And what about net?
सर वो उसके लिए सर मैं एलिजिबल नहीं था, क्योंकि यहाँ पे लाइक इंटीग्रेटेड कोर्स है ना, तो
Oh,
मतलब
अच्छा,
वो
अच्छा.
पीएससी वाला नहीं है।
Got it. No, no, one second. So you are no, no. I mean, you. Why are you not eligible for net?
सर नेट जो है वो एमएससी में या प्री फाइनल ईयर में दे सकते हैं, या तो फिर फाइनल ईयर में दे सकते हैं। लेकिन इंटीग्रेटेड एमएससी के लिए वहाँ पे कुछ लाइक मेंशन नहीं किया था। अगर मैं प्री फाइनल ईयर लिखता हूँ तो फिर वो मुझे आगे की डिटेल बीएससी डिग्री के लाइक सीजीपीए वगैरह देने होते हैं। लेकिन यहाँ
Yes.
पे वो नहीं देते, वो बीएससी डिग्री नहीं देते, बीएससी ऐसा कहीं पे लिखा नहीं होता। तो मैंने फिर अप्लाई नहीं किया।
Hmm. Got it. Okay, so you can do one thing. Okay, so you can of course write net and get, of course, definitely. But first you need to choose, since you want to do PhD in mathematics in which subject? बोला जाए in other subject, which one?
Like it should be like pure mathematics. So number
No, no,
theory
no, no.
maybe. Uh,
No, no. You want to do PhD in mathematics, right?
it's a subject.
Uh-huh.
Subject like it
So
is. I
no,
there are so
there.
many subjects I'm interested in. So sir, in
No, no.
topology,
That's it's good to hear. But the thing is, in PhD, you need to stick to it one subject, right? Otherwise, since you are interested in many things, so I think it's better for you to go with MSc Mathematics. I think it's fruitful for you also, because then only you can understand your interest, right? Because there are so many subjects. So without going through all of this, it is not possible for anyone to decide in which one you are very much interested. So I think it is better for you to go with MSc Mathematics. Then only you can decide which one is very suitable or very fruitful for you. Then you can go with PhD, right? I think that's better, because some of my friends has also done this. So that's why. Otherwise, I mean, point is that in PhD you need to stick with one subject. In physics also, right? You need to stick with one subject,
हाँ हाँ
correct? So I mean, lots of things there. That's fine, but it is not practically possible to read in everything in PhD, because there are so many things to do while you are in PhD except reading. Okay, so you can first try to go with the MSc Mathematics, then the PhD. That's better for your understanding also, and you will actually enjoy it. Really. Okay, understand?
हाँ हाँ।
Yeah. Okay, so tell me, do you have any doubt in previous sessions or previous session?
Not yet like previous। मतलब मैंने सच बोलूं तो देखा नहीं है अभी तक। मतलब आज मैं पहला पहला सेशन है।
Oh,
क्योंकि
that's
बात ये थी कि मेरे मिड सेमेस्टर एग्जाम आ रही थी और उस सब में बिजी
ah,
थी। फाइनली आज ही खत्म हुआ है एग्जाम तो मैं free हूँ।
that's good. That's good. I mean, yeah. Anyway, everything is recorded, right? So no problem. Anyway, it is recorded. So no problem. But anyway, you can in yeah, no problem. You can go with only one test, no problem. Okay, that book is well and good for beginners. You no need to worry about any other. Okay, that the book is there. So go with it.
मतलब मैं वो देख।
Hello. Yeah, if you want things like topology, geometry, of course. I mean, I think you are from physics background, so you have encountered abstract algebra also, right?
हाँ सर,
Yeah, so
ग्रुप।
those things, if you're interested, then go, then I think it's better for you first go do an MSc, or at least 1 year read these things by yourself, then go for PhD. Okay, because in PhD also I mean they will ask questions from these things, right? If you are going to do PhD in mathematics, understand? So I think that's better for you. I mean, at least it's my suggestion.
Okay, okay. Thank you.
One second. Okay, so
हाँ,
yes, yes, go
सर
ahead.
मैं ये पूछ रहा था कि जैसे पीएमआरएफ जो होती है, तो उसके लिए मैंने मतलब ऐसा सुना है कि जो उसके लिए हमें एक स्टेटमेंट चाहिए एक पीएचडी के लिए, और वो
Yes,
स्टेटमेंट लाइक स्पेसिफिक जिसका कुछ रिजल्ट मतलब निकलता हो। तो सर मतलब फिजिक्स में और इंजीनियरिंग फील्ड्स में मान सकते हैं कि उसका कुछ रिजल्ट निकले, लाइक मैथमेटिक्स में हम कैसे कुछ मतलब
uh,
पहले से, मतलब मैं थ्योरेटिकल फिजिक्स के पर्सपेक्टिव से ही पूछ रहा हूँ, क्योंकि
one
थियरी में
second,
तो
yeah, one second, one second. Please put your mic in front of your mouth so that I can hear your voice clearly.
ओके सर नाउ इज इट ऑडिबल?
Yes, yes, now it is fine actually. Yes, now tell me.
सर मैं पूछ रहा था कि पीएमआरएफ के लिए मैंने ऐसा सुना है कि मैं पूरा जो है रिसर्च प्लान जो है वो सबमिट करना होता है पीएचडी में हम जो जो करने वाले हैं वो, और एट द एंड
Yes,
रिजल्ट क्या है क्या एक्सपेक्टेड वगैरह वो भी कुछ सबमिट करना होता है। तो सर
yes.
मैथमेटिक्स में हम वो मतलब कैसे कर सकते हैं, क्योंकि हमें तो वहाँ पे रिगोरसली सब काम करना पड़ता है, बाद में हमें पता चलता है, और अगर हमें रिजल्ट पता है तो फिर हम क्यों करेंगे मतलब उसके ऊपर।
Yes, right. It's a very good question, but you no need to worry about, because in whatever the institute you are going to take admission in PS Mathematics, each and every semester you need to submit a report. Okay, so it does not matter actually. So the I mean, if the first I mean, suppose in that report which you are going to submit for PMR application, you wrote something, and then while working on that problem you diverted that from that problem and got some another result, and which is entirely different from your initial reports. So then also it is no problem, it is absolutely fine. Okay, because those things are evaluated by subject matter experts. Okay, so you I mean, not only you, nobody need to worry about these things, because since it is research, so I mean, your plan may work, may not work. If plan may not work, we need to work on some other plan, right? So there is no point of worrying about that. But first, you need to fix a problem and start with working, and then something will happen. Okay, I mean, yeah. So that's a flexibility actually. Okay, so you can change the problem in second year also. So it's not a big deal. Okay, understand? Yeah,
हाँ हाँ सर।
yeah, yeah. Okay. So okay, so let's start. Just asking one thing for curiosity: string theory is some kind of theoretical thing or some kind of laboratory thing?
Sir, it is like pure theoretical, pure. In I mean, sir, if you know something like standard model of particle physics, if you have heard,
No, I don't.
then and मतलब in simple way I can say like कि जो particles होते हैं उन्हें हम
Yes.
point particle zero dimension मतलब dimensionless particle की तरह consider करते हैं normally quantum field theory में, और मतलब particle physics में जो भी application है वहाँ पे सब में। लेकिन जो स्ट्रिंग थियरी है वो एक मॉडल है, उसमें क्या है कि मतलब पार्टिकल का जो है उसको पॉइंटलेस कंसीडर नहीं करना है, वाइब्रेटिंग स्ट्रिंग कंसीडर करना होता है, like वो ओपन स्ट्रिंग होंगे क्लोज स्ट्रिंग होंगे, और पार्टिकल की जो इंट्रिंसिक प्रॉपर्टी है जैसे उसके मास है उसके स्पिन है चार्ज है वगैरह, वो सब स्ट्रिंग के अलग अलग फ्रिक्वेंसी वाइब्रेट करेंगे उस हिसाब से उसको मिलेगा। तो इससे हमारा फ़ायदा क्या होता है कि हम हमारे पास फिजिक्स में लाइक 2 थियरी, जनरल रिलेटिविटी जो कि लाइक लार्ज स्केल में काम करती है। यूनिवर्स में जैसे कॉस्मोलॉजी बिग बैंग के आस-पास मतलब हमें अगर देखना है तो अर्थ मोशन फिर लाइक ग्रेविटेशनल लेंसिंग वगैरह हो गया। और जो स्टैंडर्ड मॉडल है वो सिर्फ लाइक पार्टिकल एक्सेलरेटर और स्मॉल लाइक प्लांक प्लांक नहीं प्लांक हो सकता है लेकिन ओके, तो वो बहुत ही स्मॉल स्केल है, नैनोमीटर एंगस्ट्रॉम वगैरह उस वहाँ पे वो काम करता है, ठीक है। लेकिन जब हम इन दोनों को यूनिफाई करते हैं ना, तो हम
हम्म,
हमारा फिजिक्स में एम एक्चुअली है कि हम चाहते हैं कि सब like, एक ही थियरी से एक ही इक्वेशन से हम सब कुछ एक्सप्लेन कर सकें, थियरी ऑफ एवरीथिंग लाइक। लेकिन रिलेटिविटी, जनरल रिलेटिविटी एंड जो क्वांटम फिजिक्स इन दोनों को यूनिफाई करते वक्त इन्फिनिटीज का कुछ प्रॉब्लम आता है। लेकिन अगर हम स्ट्रिंग थियरी के थ्रू जाते हैं ना, तो वो नहीं आता है और उसमें हम पार्टिकल उसका थ्योराइज किए, उसका नाम है ग्रेविटॉन। लेकिन वो एक्सपेरिमेंटली अभी तक वो डिटेक्ट नहीं हुआ।
got
क्वांटम ग्रेविटी इन स्ट्रिंग थियरी यू विल फाइंड सो, and it is purely theoretical,
it.
like one kind of community you can say. Okay,
Got it.
string
Got it.
theory.
Yeah. So, mm, today, one second. Hmm. Yeah. So today we shall. I mean, by the one thing is that since you have attended discuss firstly, and since you have not read this, if you wish, you can read. I mean, don't hesitate. That's what I'm saying only. Okay.
No sir, I mean if you explain some problems ना, it will be helpful क्योंकि सर मैंने जो है एक भी असाइनमेंट जो सब्जेक्टिव वाला है ना वो सबमिट नहीं
Hmm.
किया, और इस लाइक फर्स्ट वाला मैंने किया था सब्जेक्टिव, लेकिन उसके आंसर्स मेरे मैच नहीं हुए, फिर मैंने नहीं किया। तो अगर आप कुछ करते हैं मैं देखता हूँ तो मुझे आइडिया आता है कि नेक्स्ट असाइनमेंट में कैसे सॉल्व करें।
Okay. 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 So you want to start from the first assignment, right? Assignment one, right?
हाँ सर वो करेंगे तो भी चलेगा।
Yeah, yeah, okay, okay. So that so I mean the answer has already been released, right? I'm asking the team the team instructed us strictly that those assignment can only be discussed whose answers has already been released. Okay, so assignment one answer already released, right?
हाँ लेकिन सर उसका डिस्कशन भी तो शायद रिलीज हो चुका है, मतलब वो आपने लाइक वीक्स 4 या अप टू 5 वहाँ तक है ना
That's
गूगल
right.
ड्राइव
Yeah,
पे।
yeah. One second. One wow, hold a minute. Let me download it. Oh, so okay. So let's start with the assignment one. Okay. Okay. So once what is happening?
सर
Yes,
एक
yes.
मैं ये बोल रहा था कि सर अगर आप फ्री अगर आप मतलब कुछ तो फिर आप कुछ मतलब फिर या तो फिर किसी और चीज़ के जो कि आपका रिसर्च फील्ड है उसको थोड़ा बहुत एक्सप्लेन करेंगे, मतलब मैथमेटिक्स जस्ट फॉर क्यूरियोसिटी और।
Hmm. Got it. So one second. So have you read algebra topology? I mean, do you have any? I mean, do you have little bit idea?
सर अलजेब्रा के बारे में थोड़ा बहुत मतलब वो
No, no,
ग्रुप थियरी से related
group theory. Uh,
है। सर मुझे रीमान ज़ेटा फंक्शन के बारे में पता
no, no, actually, I don't know about this. I purely from algebra, topology, geometry background. I have no connection with number theory at all. Actually, okay. I mean, if you ask me to discuss about topology, geometry, then I'm fine. But I don't know anything about number theory. Okay.
है। सर नंबर टोपोलॉजी के अंदर जियोमेट्री के अंदर कहीं पे ऐसा कुछ होता है कि जहाँ पे हम रीमान ज़ेटा फंक्शन पढ़ें?
Till now, not. Till now, no. Till now, only topology uses algebra. Till now, it you did not use anything exclusive from number theory. Okay.
अच्छा कोई मैथमेटिक चीज़ मतलब हमें प्रूफ लिखना है थ्योरम का किसी की तो मतलब उस पर फॉर्मली हम कैसे लिखते हैं स्टेप बाय स्टेप देखते
Okay.
हैं।
First, let me ask you one question. So then, I mean, how you write theoretical proof in physics?
सर फिजिक्स के अंदर हमारे पास एलएचएस इक्वल टू आरएचएस ऐसा प्रूव करना मेनली होता है और या तो
Uh,
फिर कोई इक्वेशन हमारे पास होता है जैसे रिलेटिविस्टिक उसको सिर्फ ऑपरेटर पे प्रमोट किए हुए और उसके बाद जो भी रिजल्टेंट आता है बस वो उसमें लाइक ऐसा कोई फॉर्मल वे नहीं है
got it. Got it.
एज लॉन्ग एज
So in mathematics, suppose, okay, so at least you know group theory, so no problem. So let G be a group, okay, and suppose prove that uh, prove that what prove that set of elements of G of one second. So leave it. So I'm just changing the question. So G be a group and let order of G equal to order of G less than equal to 5. Okay. Show that G is abelian. So this is a one this is a theorem or this is an exercise you can assume. Okay. So tell me how to approach. Do you have any idea?
सर मुझे एबिलियन पता है कि जो मतलब ऑर्डर है वो
So
मैटर नहीं करता ए बी इक्वल टू
yes,
बी
correct,
होता है
correct, 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 correct. So this type of problem can be solved the following. So order G less than equal to 5. So assume order G is equal to 1. Means what? It is trivial. So of course trivial is abelian, right? Correct.
हम्म,
And suppose order G is equal to 2. Then of course G will be equal to Z2, right? Do you know Z2? What is?
सर जेड मतलब वो इंटीजर
Yes, yes. But what is Z suffix 2? Do you know?
सफिक्स सर मैंने पढ़ा है लेकिन याद नहीं
Okay.
मतलब मैंने कहीं पे वो देखा था इतना पढ़ा है। एक बार अगर आप थोड़ा सा भी बोलेंगे मुझे याद है
हाँ मतलब 0 and 1. Right. I mean Z mod 2 means Z by 2Z. Now, do you understand? I mean, so what are the elements? The elements of the form m plus 2z, m belongs to z. This is the element of the form z by 2z, right? Understand?
हाँ यस
Yeah. So suppose g is order 2, so g is equal to z2, okay? So of course, I mean, here of course, it does not matter. So it is abelian. Suppose order g is equal to 3. So 3 order group, it's a fact that any, I mean, order g, if order g is a prime, p is a prime, then G will be Z. Any group of prime order is cyclic group. So it is also Z3, which is I mean Z by 3 Z, which is also cyclic. Understand? So this is also abelian. Now, so the
लेकिन सर
all yes, sorry, tell me.
मतलब हम जो है हर बार मतलब ये इंटीजर नंबर से कि मतलब ग्रुप लेस देन ऑर्डर 5 मतलब उसमें तो इतने सारे मतलब हम कुछ भी लिख सकते हैं ना मतलब हम कोई आर्बिट्रेरी
Yes. The thing is here. Oh, sorry. Here, equality means isomorphism. Means what? Suppose, yeah, what I'm writing. Suppose I'm writing order G is equal to 2, right? Means what? Here, then I'm writing order G isomorphic to Z2. Means there exists a map F G to Z2, which is a group homomorphism, which is a group isomorphism. Suppose you know the bijection between two sets, right? You definitely know this, correct?
हाँ, yes.
So bijection means what? The number of elements in both two sets are same, right? So
Hmm.
there is same kind of thing known as the group isomorphism. Means what? G and Z2, there is a group isomorphism between G. I mean, their number of elements are same. Not only that, their group structure are also same. I mean, of course, it has separate algebraic structure. I mean, it has separate algebraic mathematical meaning. But moral of the story is G and Z2 are same thing. So up to isomorphism, we only need to consider about one because those two things are structure wise same, right? Isomorphism means structure same. Okay. Similarly, in topology, homeomorphism means those two spaces are structure wise same. Do you understand?
Okay. Structure wise.
Structure
हाँ.
means both, yeah, both has group structures, right?
Hmm.
Those two group structures are also same.
ओके, मतलब जैसे कि अगर जी है तो एडिशन के साथ उसका जो भी मतलब बनता है रूल्स वगैरह, तो वही सेम जेड का भी होगा.
Yeah, right, correct. But of course, it is not direct to what you have said, but it is more morally it is same. Okay. So that's what we have only considered Z2 because other things are same as Z2. That's it. Okay. Similarly, order G is equal to 3. You can start arbitrary group, but it's a fact that in any three order group is isomorphic to Z3. So after all, we need to concentrate on Z3 itself. That's it. Okay. In that way, these things goes actually. Okay. So, I'm doing. I mean, so order G4 possible, order G5 also possible. Sorry, 5 also possible, but 5 is prime, so it is isomorphic to Z. Sorry, isomorphic to Z5, and the order 4 case is possible, but there are 2 or 3 possible outcomes. So right now it is not possible to discuss. Okay, because anyway it is not algebra. I mean, it is not
हाँ.
algebra class actually. So let me show you some facts in the topology. Okay.
हाँ.
So one second. Okay. So let me give you some insights in algebraic topology. Okay. So I mean, one second. What happened? Okay. One. One second. Oh shit. Okay. So I mean, so in algebraic topology, what we look? Suppose we have a space X, okay, and we are associating a group which is obtained from X. So what do we take? By some process in algebraic topology, the basic technique is that we have some space X, and by some doing some process, we are associating that space to a group. Okay, and and in such a way that if we have any map X to Y homeomorphism, homeomorphism means those two topological spaces are same. Okay, means those there is bijection and the continuous and inverse also continuous. Okay, such that the induced map from that group to group will be an isomorphism. Okay, so what we have done, we have started with space X, associate with the group, such that f of x such any given homeomorphism we can associate another group isomorphism which is induced from that homeomorphism. Now the thing is that if corresponding induced map is an isomorphism, I mean, sorry, so if the corresponding induced map is not an isomorphism, then we can say that that map f of x to y homeomorphism not possible, right? Correct?
Sir,
Yes.
not isomorphism. Uh, it implies that it is not homomorphism. Yes, sir.
One second. No, no, no. I mean, yes. So it means that homeomorphism implies isomorphism. But if something is not isomorphism, then from the homeomorphism, I mean the homeomorphism from which that isomorphism is induced, that cannot be an homeomorphism itself, right?
Ah,
So in that way, we can determine by doing these things, we can determine that some space are isomorphic. Sorry, some space, some two given spaces are homeomorphic or not. Okay, for example, you have seen that a real line that is R, I mean, this and this thing, not homeomorphic. I mean, I don't know, but possibly you have not seen this. So means what? I mean, from R, from real line to R2, we cannot get an bijective by continuous function. Means, I mean, the point is that homeomorphic means they are structure wise same, okay? So of course, I mean, this is real and this is whole of R2. So of course, from here to here, you can't go bijectively at least. Okay, bijectively you can go, but that possibly not continuous. It is intuitively correct. But in order to argue these things concretely, I mean, concretely, you need to use this process comes from this associating an object to a group, and those things will give you the actual answer. Okay, so that's why this algebra, I mean, that is the basic motivation of algebra topology. Okay,
hmm.
understand?
Sir.
Yeah. So one second. Okay, so let wait a minute. Yeah. So okay. So let's start with now local compactness. Okay, because these videos will be recorded, so I need to go with now local compactness what comes from the class. So wait a minute.
सर एक
Yes.
मतलब वो इसी टोपोलॉजी में से सर के लेक्चर में सर वहाँ पे उन्होंने बोला था कि जो L1 एंड L2 नॉर्म है वो दोनों आइसोमेट्री नहीं है तो उसके लिए हमने एक एग्जांपल कुछ डायमंड शेप का कंसीडर किया था और उसके बाद उन्होंने बोला था कि हम ऐसा R2 में ऐसा कोई भी डिस्टेंस नहीं ले सकते कि जो जिससे मतलब दोनों के बीच का स्पेस जो है फिट टू हो क्योंकि वो डायमंड शेप में मतलब
One second, one second.
बहुत
So what is the question that L1 norm and L2 norm? What is the question?
they are not isometric to each other.
ISO?
Metric.
Oh, isometric. Yes. Now tell me. Yes, tell me. Continue.
सर तो वो उन्होंने उनके लिए एक सेट ऑफ 4 पॉइंट्स लिया था, जिसके अंदर थे प्लस माइनस 1 0 एंड 0 प्लस माइनस 1,
यस।
और वहाँ से एक शेप था। तो उसके लिए लाइक आइसोमेट्रिक के लिए एक रिक्विसाइट है कि जो L2 नॉर्म है उसके लिए भी जो हम मैप लेते हैं लाइक A2 FA का, उसका FA का भी जो डिस्टेंस है 2 पॉइंट्स का वो सेम, यहाँ पे 2 है तो वहाँ पे भी 2 ही होना चाहिए। ठीक
यस
है?
राइट।
लेकिन सर हम इसके अंदर सर अगर हम ओरिजिन शिफ्ट करते हैं तो फिर हमें ऐसा मैप मिल सकता है ना? यहाँ पे
नहीं नहीं,
मैंने
origin क्यों शिफ्ट, नो नो, आई मीन व्हाई वी शिफ्ट द origin, only we need to give the norm on the given space. The space is fixed, you, I mean, it is not allowed to change, right?
ओके,
Because it is
तो
a vector space, because it is a vector space, so origin is fixed already, right? So I mean,
फिर
you can't change those things, I mean it is not allowed to do.
ठीक है, लेकिन सर फिर तो अगर वो नहीं तो फिर हम कोई एक ऐसा कोई जो है स्क्वायर लेते हैं कि जिसके 4 साइड्स जो है वो सेम 2 2 2 2 है, और हम उसका जो है मैप लेते हैं लाइक बाइजेक्शन लेते हैं, तो फिर आइसोमेट्री हो सकता है ना?
No, no, the
पॉसिबल।
thing is that in L1 norm, what is the unit circle? And in L2 norm, sorry, yeah, in L1 norm, what is the unit sphere? That is that Borphy structure, right? And in L2 norm, what is the unit? What is the unique unit sphere? That is the circle, correct? So that's why, if we can assume that at sphere level it is isometry, then also, I mean, suppose it is isometry in the whole art, real line to real line, there is isometry. So of course, it boils down to an isometry restricted to sphere, right? Correct.
हुँ,
But in sphere level, it is not. I mean, one second. Yeah, yeah. I mean, so this is the unit sphere in L1 norm, right? And this is
हुँ,
the sphere in L2 norm. So if I mean, and isometry means distance will be preserved, right? In R2 R we have some map which preserving distance. Then if we restrict both things at sphere level, unit norm level, then also their distance will be preserved, right? So that is the reason they have started with this structure. I mean, this structure, and then they have started the circle. You understand?
हाँ।
Mm,
सर ये जो L2 है ये सर्कल होता है और L1 जो है तो ये मतलब ऐसा टाइप शेप होता है। हाँ,
yeah. Okay.
मतलब वो
So,
हमें देख के कैसे पता चलेगा?
sorry.
वो मतलब हमारे पास जो है नॉर्म के लिए एक इनइक्वालिटी है लाइक L इंफिनिटी इज़ ग्रेटर देन इक्वल L3 और लेस देन इक्वल P रूट ऑफ n इनटू L इंफिनिटी।
Yes.
मतलब यहाँ पे तो उससे हमें वो देख के कैसे पता चलता है कि ये जो है एक सर्कल होगा L2 नॉर्म R2 में, और ये इस तरीके से हम ले सकते हैं।
Okay. So what is the L2XY? I mean, what is the norm 2 of xy? Then L2 norm of xy. What is the norm? Tell me the formula.
अब L1 स्क्वायर प्लस L2 स्क्वायर मॉड दोनों का मॉड्यूलस।
Uh, and what is the norm 1 in R2? So this is norm, sorry, this is
X।
mod x plus mod y, right? Now unit sphere means what? We need to consider all those xy such that this norm is 1, right? This is means a unit sphere, correct?
हुँ,
Now, so this implies what? In L2 norm, it will give x1 square, sorry, x1 square plus x2 square 1. And L2 norm, it will give what? Mod x plus mod y is equal to 1, right?
हाँ,
And this gives the circle, correct?
हुँ,
And this gives the this Burfilet structure, right?
हुँ,
So that's why the corresponding spheres are, one is that this thing and another is the circle, right?
ओके सर। मतलब वो एक लीनियर इक्वेशन है और दूसरा जो है वो सर्कल का है।
No, no, it is not linear. It is just a equation. It is not a linear equation, right?
एंड सर सुप्रीमम का मतलब क्या होता है? सुप्रीमम और मैक्सिमम दोनों में फ़र्क क्या है? एक एग्जांपल आप अगर दे सकते हैं?
Yeah, okay. So so 0 comma 1. So consider this set. And what is the maximum of this set?
One,
No, no. Maximum means it has to belong to the 1, right?
सर वो लेस जस्ट लेस देन
No, no. By definition, what is the maximum? The maximum often given set S is that x as an x greater than x greater than equal to s for all s in S. But here it cannot have any maximum, of course, right?
हाँ
But it has supremum and it is 1, right? So basically maximum supremum almost same thing, except one fact that maximum not necessarily lie inside the set, but supremum may lie outside the set. That is the only thing. Okay,
ओके
that's what I mean. In mathematics, yeah, that is the only thing you need to remember. Understand?
हाँ यस अंडरस्टैंड
Yeah. Okay, wait for a minute. I should back after some minutes. Oh, so let's start with the local compactness. So okay, so what does it mean local compactness? Okay, so first start with definition. So look, we have some term local means the compact means local means it gives something around a neighborhood. So the Intuition is that suppose we have a given space and this locally compact means around each point we will get a compact set. Sorry, we will get an open neighborhood which will contain a compact subset. Okay. Or this is one possibility. Another possibility is every point contains a neighborhood which is contained in a compact set. Okay. So the correct definition is as follows. A space X is said to be locally compact if locally compact at X if if uh, there exists a compact subspace C that contains a neighborhood of X. Okay. So a space is locally compact at X if for so means what? So suppose X is space is locally compact at X if for there exists a compact subspace C that contains a neighborhood of X. Okay. This is what we mean by local compactness. Okay. And so there may be another way one can give the definition. So means what? At we suppose we have some point X, and I mean we around the point we can get a neighborhood which is contained in a compact subspace. That is also possible, but under certain condition. But right now, this is the definition we are taking into account. Okay. Okay.
Yes.
Yes. So according to definition, so let's see some examples. So after doing this local compactness, we will study the assignment. Okay. Okay. So consider real line. So real line is locally compact. Why? Because if we take from real line and so real line, if we take X, so there is a subspace which is a compact subspace closed interval AB which contains an open neighborhood U. So we can take it to open AB. Okay. So that's a real compact. And similarly, R to the power n also locally compact because I mean the same thing, the similar one. Okay. So now the main thing, I mean the main theorem which actually for which we need to understand the local compactness is the following. So I mean naturally the spaces which arose in topology are not only just locally compact, they are actually locally compact Hausdorff, and there are some certain criteria for which a given space becomes a locally compact Hausdorff. Okay. So a space. So by the way, do you know what does it mean by Hausdorff space? Okay. So space is said to be locally compact house drop if and only we can find a space Y satisfying the current condition X is contained inside Y. Y minus X consists a single point. A third is Y and Y dash are two spaces satisfying 1 and 2 are homeomorphic and which is equal an identity on it. So this means what? So a space is said to be local common house, and we can find a space Y as a polygonal surface firstly. X is subspace of the bigger space, and Y is obtained from X by attaching only single point. And if Y and Y dash is two space satisfying 1 and 2 means then there exists a homeomorphism H from Y to Y dash such that H restricted to X is equal to IDX. Okay. So this is what we mean. Okay.
Understood.
Yeah. So okay, right now we're not going to prove. So okay, and and this Y is known as locally compact. Sorry. This Y is known as oh shit, what happened? Yeah, this one is known as 1 point compactification fix. Okay.
Yes. सर
Yes.
यहाँ पे लाइक जो असाइनमेंट 3 थी और उसका जो सब्जेक्टिव था उसके अंदर एक क्या क्वेश्चन थी सर गिव टू सबसेट्स ए एंड बी बिलोंग ऑफ आर सच दैट लाइक ए एंड ओपन है देन क्लोज्ड है देन उसका भी ओपन है उस तरीके से लाइक उस सब के सब डिस्टिंक्ट होते हैं ठीक है
Uh-huh.
यहाँ पे सर सॉल्यूशन के अंदर जो बी सेट है उसके अंदर लिया है लाइक ओपन
Okay.
इंटरवल
Wait,
बी
wait.
एंड
So first let me finish this local compactness because that is entirely separate thing, right? I will get into this
ओके
once
हाँ
again.
हाँ
Okay. Yeah. So yeah. So this is not a one-man compactification. It is denoted by x to the power infinity. That is x with adjoint a single point outside. Actually, that is one. So okay. So this is the by this is what we mean by locally compact. Okay. And okay. So there are some many things, but okay. So let's start. So 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 should I start it from assignment one?
only sir one question is mine. Like third one. Assignment 3 में third one. Subjective assignment.
Right. Yeah, so there are some sets, and so there are many many things. Yeah, so tell me, what is the question now?
सर प्रॉब्लम ये है कि थर्ड क्वेश्चन में कि जो इसमें बी सेट लिया है उसमें लाइक ओपन इंटरवल ऑफ 3 4 यू एंड उसके मतलब एक पॉइंट लिया है सिर्फ एक पॉइंट तो जब उसको हम क्लोज करते हैं सर तो वो वहाँ पे उसका क्लोज इंटरवल 3 and 4 दिखा रहा है लेकिन सर उसका लाइक क्लोज इंटरवल 3 to 5 नहीं आएगा.
No, no, I mean, this is 3, this is 4, and only we have 5. Okay. So
Hmm.
we are taking the closure. Closure means what? It contains all of the limit points. So here 3 is the itself limit point, 5 is a, sorry, 4 is the limit point, but 5 is not a limit point. So I mean, so only it will be 3, 4 unique 5, right? Because anyway singleton 5 is closed, right? I mean, please tell me the confusion.
कंफ्यूजन
Why
सर मतलब मैंने
why
तो
you wait a minute, wait a minute. জলের উপরে হ্যাঁ জল মনে লাগবে, জলটা ভরে যাওয়া উচিত ছিল। Disgusting. So yeah, so tell me the confusion. I mean, why you think that's like you? I mean, so you have the, so do you have the knowledge of um, uh, limit point? So you have the knowledge of limit point, right?
हाँ सर लिमिट मीन्स राइट मोस्ट लेफ्ट
Sorry,
मोस्ट
sorry. Please be louder and
अगर
louder.
अगर हमारे पास एक एक्सेस है उसके अंदर दो पॉइंट अगर हम लेते हैं तो लाइक ए एंड बी सो राइट मोस्ट है एंड लेफ्ट मोस्ट है तो उनको मैं लिमिट सही है.
That is okay. That is okay. But 5 is a singleton set. Okay. I mean, it is totally distinct. So singleton is the closed set. So whenever you're taking the closure, it will be only that set, right?
मतलब जो भी हमारे पास क्लोजर है तो उसके अंदर लिमिट पॉइंट्स मतलब जो बीच वाले पॉइंट्स है वो सब और जो भी लास्ट में लाइक कंटिन्यूअसली वहाँ पे जाते हो तो जो पॉइंट मिलता है यहाँ पे लेफ्ट हैंड साइड में जाते हो जो पॉइंट मिलता है वो सब हम लेते हैं.
Yeah, correct. Yeah, yeah, right. But in between, if you singleton, then it will only be that set. Okay, understand?
तो सर मतलब अगर हम लेते हैं कि बी इक्वल टू अगर इंटीजर नंबर का सेट लेते हैं तो फिर उसका क्लोज्ड क्या बनेगा.
It is. I mean, its closure will be only z itself because each point. I mean, so it has no limit point, right? So the things are distinct here. It has no limit point, right? So that's why. Okay, so you don't have the knowledge of real analysis also, right? I just remembered right now,
सर
right?
सर इतना लाइक मैथमेटिक्स के पर्सपेक्टिव से नहीं है मतलब फिजिक्स
Okay, so
लाइक
I think so.
आई नो.
So that's what I have just told you. Go with the MSc mathematics. Okay. I mean, look, the thing is, real analysis, basic algebra, basic group theory are very basic of mathematics. Okay. Without doing this, you can't enter clean PhD. Understand? So please either read it by yourself or please go with MSc mathematics. But I think it's better also with read it by yourself. Okay. That is also good. Okay. But the thing is, first you need to learn this thing. Then only you can do PhD in mathematics. Okay.
एंड सर अगर मान लो कि हमारे पास बी है वो सब रेशनल नंबर का सेट है तो फिर उसका
Yes.
क्लोजर का.
So its closure is the entire real line. It has entirely different proof. But the intuitively thing is that if I mean if you take any interval in real line, it of course contain an element of and it if you take any interval real line, it of course contain a rational number, right?
हाँ.
So So in that way, its closure should be whole of R. That is the intuition. Now, mathematical congruity is slightly different actually. Okay.
और सर अगर हमारे पास इरेशनल नंबर का सेट है तो उसका भी क्लोजर लाइक रियल लाइन ही होगा.
Yes, correct, correct. The same argument. Okay. So I mean, since you have confidence with basic things also, I think it's better to go with Messi or first you need to learn this thing. Okay, because these are actually very basic, right? I mean, it is not ignorable. So that's what I'm trying to say. Okay. So wait. Okay, okay, so let's start with the assignment one. Okay, one minute. Oh. So, okay, sorry. So, first question of the assignment one is, uh, yeah, the first question assignment one is, every vector space over K has a norm. Okay, K is a field, so take it real line, forget about it. Sorry, it is BS means vector space. I'm sorry for that. Okay. Hmm.
Yes.
So, tell me how to do. I mean, you have any idea? So look in L2 norm, L1 norm, you have some kind of process, right? But here what you can do, you can use that things also, no problem. But what is the technique? Any process? So look, I mean, in so suppose in R2, I mean, I'm asking you, I mean, just I'm explaining what is a possible guess. Okay. So suppose you have R2. Okay. So any point is x comma y. So it is x comma 0 plus 0 comma y. This is x comma 1 0 plus this is 0 comma 1 y, right? So this 1 comma 0 and 0 comma 1 are the basis elements, right? So forget about this. And then what is the norm? The norm, so it is, so there is one norm this and there is another type of norm like sorry, this. Okay, there are many things like that, correct? So this gives the possibility of doing things like this. Suppose we have vector space over R, as suppose we have basis alpha 1, alpha 2, alpha n, sorry, leave it. Basis we should always denote by b1, b2, bn. Okay. Now, so we can take any element can be written as alpha 1 b1 plus alpha n bn. Then we can define v to be alpha 1 plus alpha 2 plus alpha n. And you can check that this definition is itself a norm. I mean, you can also define V to be, you can define to be alpha 1 square, alpha, sorry, here you should mod alpha, right? Okay. Plus alpha 3 square plus alpha n square, and of course the under root. So you can take the definition that also will be a norm. So when there are many norm you can define, but the idea is that like like in real line you can any element can be written as base sum of bases, so here also you are writing some element as a basis and you are taking the sum of some, I mean the sum of moduluses of those coefficients. Okay, that is the process. Understand? I mean, that is the intuition. Now, actually, you can prove that this is the norm, and so this tells our intuition works. Okay, do you understand?
Yeah. Okay.
Yeah. Okay. So, so question is as follows. So, like, B is a vector space over K. Okay. Let W be linear subspace of B. Now, if is a norm on W, then there exists a norm dash on V such that, so what is the question? We have a already vector space given at W is the space and there is a norm on W. Now question is that this norm can be extended to whole of V, thus that restricted on W, those two norms are equal. Okay, so that is the question. I mean that is we need to prove. So think about it how to do. I shall back up in 2 minutes. Okay. So yeah, so what to do? So look, so look, so W is our space. Okay. So uh, so we have and quotient is V by W. Okay, and it's a fact that V can be written as W plus V by W. Okay, so we can give a norm on V by W.
uh,
Why? Yes, tell me.
सर ये
Yes, yes.
क्वेश्चन
Tell me.
है एग्जैक्टली मतलब कौन सी असाइनमेंट
Sorry, I didn't get you.
मैं असाइनमेंट 3 की बात कर रहा हूँ सर असाइनमेंट 3 का जो आपने बोला ना फर्स्ट शाहरुख का
No,
जो
we have started with the
हाँ
first assignment, right? Assignment one, not three, right?
असाइनमेंट 1 ओके 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 तो मतलब असाइनमेंट 1 वो ट्रू फॉल्स वाला है वहाँ से
No, I mean that. Uh, yes, correct. Yes, that true false.
ओके सर
So, so I mean, so okay, I have not mentioned that true false, but I hope that you have the question in front of you. That's all. Okay, so we can define a norm here in V quotient W, call it just two. Then we can give norm V to be so any element can be written V is equal to U plus W. U belongs to W and W belongs to V by W. So we can define norm U to be norm V to be norm U plus norm W dash. Okay, and of course it is these two norms are equal or W. So this is the argument. So only technique is you need to consider the V by W, and by the previous question there is a norm on it. So we can give another normal V by W and V isomorphic to W plus V by W. So that's why this argument works. Okay, this is what it is. Understand? Yeah. So the next question. Uh, mm, so there is one question we got to make fix. So I'm just leaving it. Mm, yeah. So there is one next question. That's another question number nine. The question says that suppose let V suppose let V a vector space and Vi be a basis for. Okay. Then there exists a norm on V such that this is equal to 1 for all I. I mean, of course, I belongs to I. So basically, you have some vector space, you have some basis, you need to find a norm which is one on each of these elements. Okay. So can you please pause? Can you make a guess how what is the process?
सर रिपेयर से बेसिस एंड अगर हमको नॉर्म चाहिए तो हम वही जो आपने लाइक पहले बोला ना कि मोड लेके फिर स्क्वायर करके फिर प्रूफ
Yeah, right. So yeah, correct. So basically, if V is alpha I V I summation, define norm V is equal to you're defining summation mod alpha I. So of course it is one on base element, right? So that's what it is. Okay, so let me explain. So, oh, so there's nothing here. Let me define assignment. Oh, so trying to get some nice question. Yeah. Okay. So this is one very nice question. So this is from assignment three itself. Only. Question one. Suppose X and Y are two metric spaces. But if you have any issue of understanding my handwriting, please let me know. Okay? Suppose X and metric space and f of x to y continuous. If xn is Cauchy, equals x, if xn is Cauchy sequence in y. So also, do you know what does it mean Cauchy sequence?
सर कन्वर्जेंट वो जीरो जीरो कन्वर्ट होके जीरो
No, no, Cauchy sequence
नो
means a sequence xn is said to be Cauchy. If for in epsilon greater than 0, there exists cases that xn minus xn less than epsilon for all n greater than equal to. This is what by mean Cauchy sequence. Okay. So the question is that, so we have two matrix spaces and function is continuous. You check that is Cauchy equals to Cauchy one and it is a true or false question. Okay. So basically, look, the answer is false. Okay. So basically, you need to somehow come up with a sequence which is Cauchy, but whose f values are not Cauchy. So yeah, so that example what is given assignment is actually easy. So taking x equal to 0 infinity to y, usual metric, and define a function f x to y, where x goes to 1 by x. Of course, it is continuous, but the sequence 1 by n Cauchy as a convergent, but the sequence f of 1 by n, this is n, and the sequence n is not Cauchy because it is not even convergent. So that's why it is false. So I mean, I don't know in between what which part you have understood, but the thing is that you need to somehow come up with an element which is continuous and one minus Cauchy. I mean, sequence is Cauchy, but image is not Cauchy. That is what you understand.
सर कौन सी सीक्वेंस मतलब अगर हमारे पास जो है मतलब एंड टर्म एंड एम टर्म का अगर डिफरेंस लेते हैं तो लेस देन वो एप्सिलॉन आना चाहिए और वो एप्सिलॉन लाइक वो फाइनाइट ठीक है तो फॉर एग्जांपल अगर हम लिखते हैं लाइक 1 2 3 4 5 6 एंड सो ऑन तो क्या वो कौन सी सीक्वेंस होती है
Just please repeat.
सर कॉची सीक्वेंस के लिए हमें चाहिए लाइक एक्स एम माइनस एक्स एन का जो मोड है वो लेस देन एप्सिलॉन और एप्सिलॉन जो है वो ग्रेटर देन जीरो मतलब कोई भी एक वो नंबर है ठीक है तो इसके लिए मतलब एन एंड एम जो है वो हमें ऑर्डर में ही लेना होगा वन एंड टू एंड वन एंड थ्री एन इक्वल्स वन एंड एम इक्वल्स थ्री कि फिर हम कोई भी लाइक लास्ट टर्म एंड फर्स्ट टर्म का भी डिफरेंस ले सकते हैं
No, 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 no. No, no. Cauchy means after certain terms, all those after certain terms, everything are coming nearer and nearer. Okay, so this is what the Cauchy means. And that thing which was said, it is the convergent. Like you have some term fixed, and after the final step, all the other terms uh, is coming nearer and nearer to the fixed term. That is called a convergence. Okay, so these, I mean, these are these two are different. Okay.
मतलब जो एवरी कन्वर्जन सीक्वेंस है वो कौची सीक्वेंस होगी
Yes, yes, Cauchy and convergent are same thing. Like Cauchy implies convergent and convergence implies Cauchy, but it is only in with real line with usual topology. Okay, it is not true in general. Okay,
ओके
So yeah. So there is one question, which is actually useful. So let X be a topological space, and here is bijective continuous. Then A is a homeomorph. So given a space, a topological space, and is equal continuous, you should check that F is a homeomorphic. So look, so because it is true or false. So anyway, it is the answer is going to be false. So basically, so false. Okay. So 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 can you think about a possible counter example? Okay, wait. Since you don't have that knowledge of that, so okay, so leave it. No, no. So it is not possible right now for you to solve. Anyway, that they're given. So in the counter example, they took x to be real line with indiscrete topology. Okay, so this question, okay, this question I have some better answer. I will give that for the next session or next session. Okay. So, that's a good question. Okay, so suppose is a basis of a space X with boundary empty. Then A is both open and closed. So, so what is the process? I mean, look, from definitions, there are many ways, but in but look, I mean, so there are one formula boundary is that A closure minus A interior. Now it is given to be empty, right? So this one, A closure is equal to A interior. This is equal, but we know that A interior contains A and this contains A closure. And these two things are equal. So of course, A interior is equal to A is equal to A closure. So that's why A is both open as well as closed. Okay. So this is the thing. You understand?
Yes, understood.
Mm,
सर
yes.
सर ये थर्ड असाइनमेंट में जो सब्जेक्टिव है उसके अंदर जो फर्स्ट क्वेश्चन है उसके अंदर हमें वो आर एन दिया है और उसका नॉर्म दिया है और हमें वो प्रूव करना है कि अगर ये आइसोमेट्रिक है तो एम इक्वल टू एन होगा।
Hmm.
तो सर उसके अंदर हम जो है नॉर्म है वो यूक्लिडियन नॉर्म है, ठीक है। तो हम
Yes.
मतलब ऐसा कर सकते हैं ना कि x1 x2 अप टू xn आर एन के लिए उसका जो स्क्वायर है वो अगर आप दोनों इक्वल नहीं है तो या तो मतलब एम में प्लस होगा या तो एम में एक माइनस होगा। फिर हम अगर दोनों को इक्वेट करते हैं तो अब वहाँ पे अप टू एम जाएगा और यहाँ पे सिर्फ अप टू एन, तो लाइक जो डिफरेंस है वहाँ पे लाइक पॉसिबिलिटीज है ना, जैसे कि x1 x n प्लस ए माइनस x n प्लस a माइनस 1 अप टू एक्स स्क्वायर, वो सबका स्क्वायर मतलब इज इक्वल टू वो जीरो।
Oh, no, 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 look. Isometry means there exists a map F which is a linear plus bijective possibly from what to where Rn to Rm such that norm x equal to norm fx. Now we need to show that these are not isometric means here does not exist any such function. That is, I mean, what you are giving the argument, it comes maybe from is from the identity map, right? But you can't find any map from Rn to Rm satisfying this condition. This is what you need to prove. Okay, I mean, I understand. So you are saying that this is square can be written as x1 square plus xn square plus xn plus 1 square plus xn square. You are saying that this might be zero. That is right, but you will check
हाँ
all possible cases not possible. Then only the answer will be done. Okay, do you understand?
ठीक है सर, तो फिर हम ऑल पॉसिबल मतलब वो कैसे चेक करेंगे, मतलब ये जो है
Aha,
ये।
I mean, yes, that is the solution. How to solve that is the solution, right? So the technique is as follows. I mean, so I am going to the solution because this solution actually very tricky solution. So let me discuss it. I mean, okay. So if you are thinking that is this type of thing obvious, no, this is not. This is not obvious. Okay, this is something needed to be proved. Okay, so
ओके।
so suppose we have a Rn to Rn isomer. So we are defining map G to be Rm to Rn by x goes to fx minus. Okay. So G0 is 0 and G is also isometric. Okay. Yeah, so G is also an isometry. Okay. So now since G0 is equal to 0, this is what? Order of Gu is equal to order of U for all of U belongs to Rm. So Gu dot gv is equal to u dot v for all uv. This implies order of g of u plus av minus gu minus agv is equal to 0 for all uv belongs to Rf. So since this norm is 0, this will what? This implies gu plus av is equal to gu plus h. So it means what? G is the linear map. Okay. So G is linear, and of course G is bijective. So M has to be equal. So this is way this can only this problem only can be solved.
सर
Yes.
मतलब ये जी जीरो इक्वल टू जीरो का नीचे के स्टेप्स हो रहा है लेकिन जो ऊपर
Sorry.
जी जीरो इक्वल टू जीरो सर कैसे जी
From
जीरो
G. Oh, okay. Yes. Then
सर मतलब वो कैसे लिया जी जीरो इक्वल टू जीरो
no, no. This is the trick to choose a function G like fx minus h0, so that g0 is equal to 0 is coming. That is the only reason. Okay.
एंड सर यहाँ पे जो आपने मोड लिया है नॉर्म सॉरी नॉर्म जो लिया है तो उसके अंदर वो स्क्वायर या तो मैं जानता हूँ मतलब हमें वो क्वेश्चन में दिया हुआ कि वो सिर्फ यूक्लिडियन नॉर्म है सर तो स्क्वायर नहीं होगा मतलब जी यू प्लस ए यू स्क्वायर माइनस जी स्क्वायर
No, no.
नॉर्म के लिए यहाँ पे हम जो नॉर्म ले रहे हैं ना जी का
हाँ हाँ हाँ
और उसके लिए मतलब इन सब का स्क्वायर होके फिर ऐड नहीं होगा और फिर उसका रूट आएगा ऐसा क्योंकि
हाँ
यहाँ
that
पे जो नॉर्म ऐसा यहाँ पे तो जो नॉर्म है वो तो यूक्लिडियन नॉर्म है ना तो मतलब यूक्लिडियन नॉर्म का तो मतलब यही होता है सर हाउ
no no.
कैन
So no no. One second. You are saying that here it should be squares, right?
हाँ यहाँ पे और नीचे भी जी यू प्लस ए वी जो है ना थर्ड इस लाल लाइन के नीचे थर्ड स्टेप
Yes, this one,
नो नो उसके नीचे
this one.
हाँ
No 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 no. Look, in Euclidean's norm of x, sorry, the norm of x y is square is equal to this is square plus y square. Okay, but
हाँ
only this is the norm. Okay, and this is the so this norm is root over of this. We are only considering this norm. We are not writing the explicit expression here. Okay,
हाँ
no no. I mean, look, G is an isometry, so that's why norm GU is equal to norm U. Okay, and this thing says that gu is equal to gb. I mean, yes, sorry, I mean, yes, I mean, no, I mean, the point is that, I mean, here 2 doesn't matter, but from this part to this part we are doing the square and then pulling those things equal, then it is coming gu dot gv is equal to u dot v. But I mean, from here to here we need to do the square. Okay, but this lines comes directly from this possibly, but you need to do the square also. I mean, just I am writing it directly. Okay, but Possibly while calculation you need to do the square and you need to check that square is 0, then only you can check the norm is 0, right? Okay, you're right, correct, sorry.
नहीं नहीं सर, मतलब मैं बोल रहा हूँ कि उसके जो नीचे के स्टेप में हमने किया ना कि जी यू प्लस ए वी इक्वल टू जी यू प्लस ए जी वी, तो
uh,
सर वहाँ पे वो दोनों स्क्वायर के इक्वल नहीं होगा, जैसे कि जी स्क्वायर यू प्लस ए वी इक्वल टू जी स्क्वायर यू प्लस ए स्क्वायर जी स्क्वायर वी।
I mean this line you were saying, right?
हाँ
No, I mean if you take the square, I mean yes, if you do the square then it will, this formula will get sorted in three terms, right?
हाँ, लेकिन सर उसके बाद फिर वो लीनियर नहीं होगा ना।
No, no, no. Now that is okay, it will not be linear, but only we need to do, then there are some elements, right? Then we need to check that that thing is 0. Then only it will be 0, so the norm is 0. That's it. Okay. I mean, we are directly checking that this norm is 0 and this implies this equal to this. I mean, from this line to this line, is it clear?
नो सर, वहीं पे डाउट है, वहाँ से नीचे आने में।
Oh, yeah. So, I mean, by definition of norm, norm x equal to 0 if and only if x equal to 0. This is a definition of norm.
हाँ,
You understand?
ओके 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 सर, हाँ वो मतलब वो पूरी एक ही क्वांटिटी है, लाइक जी यू प्लस ए बी माइनस जी यू
Yes,
माइनस ए
yes,
जी
yes.
बी। ओके। हाँ
Correct, correct, correct.
हाँ, ओके सर, अब समझ में आया।
Hmm. Oh, so you're right. So, so now can you please tell me? Just I am asking the question out of assignment. I mean, out of assignment. So suppose, so I mean, how to calculate the boundary of circle?
सर बाउंड्री जो है वो अ, जो ओपन सेट है उसको क्लोज में से माइनस करना है, क्लोज माइनस ओपन
Yes,
इक्वल टू
that is
बाउंड्री।
closer of S1 minus its
हाँ
open part, right? So anyway, S1 is closed. So it will be S1 minus. Now set this with S1, right? Correct. So so anyway, so by definition of boundary, by definition it is a closed set, right? So this means what? So this means that any open set cannot be in boundary. So open interval 1 2 cannot be boundary. I mean, just I'm just indicating these things because these are some kind of tricky questions one might face in exams actually. So in open set cannot be boundary. Similarly, yeah. So what will be? Yes, tell me.
सर बाउंडेड मतलब ये जो बाउंड्री हम फाइंड कर सकते हैं कि नहीं वो सर, तो अगर मतलब इसका जो क्लोज्ड सेट होगा वो क्लोज इंटरवल वन टू होगा, तो इसको फिर हम अगर ओपन में से सब्सट्रैक्ट करते हैं तो उसका जो बाउंड है वो वन एंड टू आ सकता
No, no,
है।
no, 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 no. What I mean. Look, boundary is closure minus interior. So boundary is a closed set. Boundary of an in boundary of any sense is a closed, right? So this means what? This means any open set cannot be a boundary. Do you understand what does it mean? Do you understand what does it mean?
ओपन सेट कैन नॉट बी अ बाउंड्री बट इट उसका बाउंड्री हो सकता है like,
Yeah, that is okay. But the thing is that any open set cannot be a boundary of some other set because it is
oh,
open. That's the only thing I want to mention. Okay? Yeah. So hmm. so okay. So can you please tell me the definition of Hausdorff?
sir, I don't.
Okay. So in a space X is said to be Hausdorff if any two points X and Y there is open set U containing U, A containing X and B containing Y, so the U intersection is equal to empty. So this is what by Hausdorff means to mean. Do you understand? X is an Hausdorff space means if we take any random point, of course not equal, then we can get an open set U and V contain those two points respectively such that they have disjoint intersection. Sorry, this not empty intersection. Then such a space is called a Hausdorff space. Okay.
हाँ.
So, so can you show that real line with usual metric is Hausdorff? At intuitively, is it possible? Can you show? Take your time and think about it just first. Think about a minute.
सर रियल लाइन में जो नंबर्स है वो सर थोड़ा अलग अलग है ना, तो वहाँ पे अगर हम सेम नंबर नहीं लेते हैं तो वो सब हैंड्स लॉक हो, क्योंकि नंबर का फाइव
So,
होता है.
so sorry. If you take the same number, then
कैन टेक एनी अदर नंबर, उन दोनों का
yes.
पॉइंट्स है ना वो दोनों, तो मतलब वो तो कहेंगे.
I mean, हाँ. I mean, इस तरीके से दो ओपन तो मिल ही जाएगा, right? Correct.
हाँ.
You are right. Correct. So yeah, it is. So that's what is Hausdorff. So similarly, can you show that any metric space is housed or can you show any metric is housed? I mean, look, in real analysis, we have concept of distance. In metric space, we have concept of distance, right? So we have some x, okay, and we are taking this distance, and we are taking half of the distance. I mean, one fourth of this whole distance, and we are taking the open ball around this distance, and around this distance. Of course, these are disjoint, right?
Hmm.
So any metric space is also Hausdorff space. And similarly, since any norm gives metric, so any normed space is an Hausdorff space. From norm to metric, then metric to Hausdorff. Okay. So do you know that? Yes, tell me.
सर मैं ये पूछ रहा था कि अगर हमारे पास एक स्फीयर है तो उसका जो है सरफेस एरिया कुछ होता है अगर हमारे पास टू डायमेंशन है तो सर्कल है तो उसका जो लाइक पेरीफेरी कुछ होता है मतलब टू पाई आर फोर पाई आर स्क्वायर एंड सो ऑन
Yes,
सर इस
yes.
तरीके से अगर हमारे पास एन डायमेंशन में है तो उसका कुछ गामा फंक्शन से रिलेटेड फॉर्मूला आता है सर मैंने उसका डेरिवेशन देखा था तो उसके अंदर वो गॉसियन इंटीग्रल को दो अलग-अलग तरीके से इवैल्यूएट करके फिर उसको इक्वेट करके उसका वॉल्यूम फाइंड करते हैं। तो सर उन्होंने गॉसियन इंटीग्रल ही क्यों चूज़ किया मतलब उसका कोई स्पेशलिटी?
I mean, look, this. I mean, look. I mean, this has nothing to do with topology. This is purely applied, by the way. This is
आई
purely
थिंक
applied.
जियोमेट्री से रिलेटेड था तो मैंने मतलब पूछना सिर्फ याद आया।
Uh,
इफ यू नो
no, no,
समथिंग
no, 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 no. It is entirely applied. I mean, look. I mean, everything comes from. I mean, these things, of course, comes from geometry. But when you want to compute something, then these things comes in applied question, not in differential geometry also. Okay, because differential geometry deals with other things, not this type of thing. Okay,
ओके सर।
that's so that's why any metric is house. So, oh, wait. One.
सर
Yes.
सर जो पीएमआरएफ है उसके लिए मतलब अगर हमें कोई स्टाइपेंड वगैरह मिलता है तो हमें मतलब उस तरीके से लाइक इन्वेस्ट भी तो करना होता है ना कि
या
रिसर्च
क्या,
के लिए
या क्या मिलता है, मैं समझा नहीं, सॉरी।
स्टाइपेंड जो भी मिलता है
सॉरी, व्हाट?
स्टाइपेंड
ओ,
फेलोशिप।
यस यस यस
हाँ
यस।
हाँ, मतलब अगर वो फिजिक्स में है या एक्सपेरिमेंट्स में रिलेटेड कुछ है तो फिर हम मतलब इक्विपमेंट्स या तो फिर लैब फैसिलिटीज़ के या तो फिर जाने आने के लिए कहीं पे यूज़ करेंगे।
यस, यू
मतलब
राइट।
तो मतलब
यस यस यस।
मैथमेटिक्स तो लाइक वो थ्योरेटिकल है उसमें तो लाइक पेन और पेपर चाहिए और मे बी कभी कंप्यूटर मैथमेटिका वगैरह कुछ तो सर
Yes,
ये
yes,
भी
you can. Yes, yes, you can
हाँ
buy the necessary lab things also.
तो सर मतलब जो उसके लिए तो फिर हम मतलब ये फंड्स का हम यूज़ कहाँ कर सकते हैं
Yes, yes, of
हॉस्पिटल के
course.
लिए।
Yes, yes, of course.
सर मैं पूछ रहा हूँ कि मतलब हम कैसे यूज़ कर सकते हैं लाइक फंड्स को क्योर
Like
करने
that's what you said now, that lab, then research visits, lab equipments, lab experiments, and all.
मतलब मैथमेटिक्स में मतलब हमें क्या चाहिए।
Oh, okay, okay, got it. So, yeah, so there are some softwares I need to use, okay, which are paid softwares, okay. So, so those since these are paid software, so I can use that fund for in the software, okay.
लेकिन सर वो तो इंस्टीट्यूट भी कभी कभी प्रोवाइड करता है ना
You are right,
इंस्टीट्यूट।
but not all the softwares. Okay, not all the software paid. But suppose there is one premium version of Wolfram Alpha, okay, premium version that usually institutes will not provide it. Okay, that you need to purchase. If necessary, then you need to purchase. Okay, understand?
हाँ
And so this is one important thing. Like, so like suppose yeah, some R computations give some big size data. Okay, now for big size data we need to keep it on online, so for that we need to pay for the cloud storage also. So for that you can use that. Okay, in that way, in that way, understand?
हाँ
Okay, so okay, so let's stop here. Okay, so
हाँ थैंक यू फॉर एवरीथिंग।
we will meet in the next session.
थैंक यू वेरी मच।